Now let's exercise what we learned from the first principle. Let's exercise it by considering some examples. So let's begin with example number 1. We are going to go over tons of examples so you can master and understand how to use the first principle very well. So number 1, consider y to be equals to 5x plus 4. So what would be the y dx? So since y is the same as f of x, so it simply means f of x is equals to 5x plus 4. And from the definition of derivative, I'm just going to write that right here without getting rid of it anymore. We said that will be equals to the limit. As now, since we are considering tons of examples, writing changing x continuously might a little bit take time. So instead I will replace with h. As h approaches 0 of f of x plus h, the minus f of x all divided by h. Perfect. So that is the formula we consider using to find the derivative. So now if f of x is 5x plus 4, what would be f of x plus h? Well, what it means makes sense is that wherever we find x in f of x, we should replace with x plus h. So therefore the 5x will becomes 5 in the bracket of x plus h, then plus 4. Now expanded the bracket, we have 5x plus 5h plus 4. So that's f of x plus h. So now we can find the derivative. So the y dx, which is equals to f prime of x, will now be equals to the limit as h approaches 0. Then we have 5x plus 5h plus 4, then minus f of x. This is f of x, okay? That's 5x plus 4. Since it's a binomial, let's put it in a bracket, okay? So the negative can take it, then all divided by h. And simplifying this forward, we have the limit as h approaches 0 of 5x plus 5h plus 4. Then when we distribute the negative, we have minus 5x minus 4 all divided by h. And eventually this results in the limit as h approaches 0. Notice that 5x cancels 5x and positive 4 cancels negative 4. Okay, perfect. So left over is just 5h all divided by h. And the h cancels out. Since we have no h left over, so this results in 5. So that is the derivative of 5x plus 4. So f prime of x is 5 if f of x is 5x plus 4. And that is the solution to the first problem. Now on to number 2. So feel free to pause the video and figure this out yourself. So consider the function y equals to x squared plus 2x plus 3. Okay, it's still a polynomial, typically a trinomial. Okay, perfect. Now how can we determine the derivative of this function? So since y is equal to f of x, so it means f of x is x squared plus 2x plus 3. Okay, I've actually got rid of the derivative, but let's get that. Okay, and from the definition, okay, let me just keep on writing it so you can also be used to it. So from the definition of derivative from first principle, the y dx equals the limit as h approaches 0 of f of x plus h, the minus f of x all divided by h. Now if f of x is x squared plus 2x plus 3, then what would be f of x plus h? So f of x plus h would be equals, wherever we see x here, we should replace with x plus h. So therefore we have x plus h all squared plus 2 multiplied by x plus h, then plus 3. Perfect. So therefore we can now expand x plus h, f of x plus h. So x plus h squared simply means x plus h multiplied by x plus h, and distributing these two, we have plus 2x plus 2h plus 3. And simplifying forward, we have f of x plus h. Now let's expand this bracket. Okay, so x times x, that's x squared. So x times h, that's xh plus xh. H times x, that's hx, which is the same thing as xh. Okay, and h times h, that's h squared plus h squared plus 2x plus 2h plus 3. Perfect. So now simplifying forward, we have x squared. Now these are like terms, plus 2x h plus h squared plus 2x plus 2h plus 3. Perfect. Okay, let me write that properly. Okay, I actually want to write 3. Okay, we are fully good. So plus 3. So that is f of x plus h. You notice that there's no any like terms left over. We would have had or subtract them. So now let's replace in the first principle formula. So therefore we now have the y dx to be equals to the limit as h approaches 0 of f of x plus h, which is this entire expression right here. So that's x squared plus 2xh plus h squared, then plus 2x plus 2h, then plus 3, then minus f of x. So that's minus, since the trinomial, we need to put it in the bracket for the negative to take effect. Plus 3, as I mean it's just a monomial, whereby it's just one term, you don't really need to put it in the bracket. Okay, so all divided by h. So we are out of space, so they just getting from stops. Okay, so right now, simplifying forward, the y dx is now equal to the limit as h approaches 0 of x squared plus 2x h plus h squared plus 2x plus 2h plus 3. Then let me get rid of this one as well. Then let negative expand bracket one after the other. So we are distributing the negative respectively. Okay, so therefore we have negative x squared. Okay, this is squared. Okay, squared actually. Negative 2x and negative 3. You know, it's changed everything to negative. Then everything entirely divided by h. Divided by h. Give it. So right now, if we simplify forward, we have the limit as h approaches 0 of so now let's delete the like terms. So these cancels out. X squared cancels x squared. Okay, let me use a different color for that. X squared cancels negative x squared. Then positive 2x cancels negative 2x. Positive 3 cancels negative 3. Incredible. Now you notice that we are now left over with the limit as h approaches 0. We are now left over with 2xh, then h squared plus h squared, then we have 2h plus 2h plus 2h, then all divided by h. So right now at the numerator, what I will do is just to factor out h, and now we now have the limit as h approaches 0 of h, then in brackets. If I factor out h, left over is 2x right here, and for the next one we have h, and for the last one we have 2, then all divided by h. Notice that the h can now cancel out and can now be left over with the limit as h approaches 0 of 2x plus h plus 2. Now as h approaches 0, if we plug in 0 as h right in the expression, notice that we'll be left over with 2x plus 2. So that is our final answer. So therefore, using first principle, the derivative of y equals x squared plus 2x plus 3 is simply 2x plus 2. And that is it. Now on to example number 3. Hopefully you are now getting used to the logic. So the goal is just to find a way to get rid of h to avoid undefined function and simplify whatever you are left with. So on to question number 3. Consider the function f of x equals to 1 over x. So feel free to pause the video and find f prime of x which correspond to the y dx. So let's begin. Now from the definition, the y dx equals f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Perfect. Now since f of x is 1 by x, then f of x plus h, which I'm writing right here, means wherever we see x in f of x, we should replace with x plus h, which means f of x plus h becomes 1 by x plus h. So now I can substitute in the first principle formula. So therefore, the y dx becomes the limit as h approaches 0 of 1 by x plus h and minus 1 by x and all divided by h. Perfect. So right now I'm having a compound fraction which I will need to simplify by reciprocating. So this long division, let me change it to the regular division. Then we have the limit as h approaches 0 of 1 by x plus h, the minus 1 by x, so divided by h. So this is simplified forward to the limit. Okay, let me write that here. As h approaches 0 of 1 by x plus h minus 1 over x, then multiply by 1 over h. Perfect. So first, let me combine these two expressions. So we now have the limit as x approaches, as h approaches 0. Now the LCM can be x plus h times x. So x multiplied by x plus h. Now x plus h in this whole term, we are left with x. X times 1, that's x. So we have x minus. Now x in this whole term as x plus h multiplied by 1 gives x plus h back minus x plus h. Then we are multiplying by 1 over h. Perfect. Excuse me. So now we can get rid of this as you know when use of that. So now we have the y dx to be equals to the limit as h approaches 0 of x. So I will distribute the negative sign respectively. So x minus h, then all divided by, so let me just multiply this. I'm not expanded bracket, I'm just trying to multiply. So I have xh, then x plus h. Perfect. Now simplifying forward, we have the limit as h approaches 0. Now notice that this cancels out, negative x, positive x, and left over is negative h over xh. Then we have x plus h. Perfect. Now notice that this h can cancel at this point as well. We can now have the derivative the y dx to be equals to the limit as h approaches 0 of negative 1 divided by, so left over is just x multiplied by x plus h, x times x plus h. Perfect. Now at this point we can plug in the value h is approaching, as that won't make us to have any undefined function anymore. So as h approaches 0, we are now left to 1 divided by x multiplied by x plus 0. And this is simplified forward to the negative 1 divided by x multiplied by x, which is simply -1 over x squared. And finally, if we rearrange this, we have -x raised to the power -2. So this is the derivative of 1 by x if f of x is 1 over x. And that is the solution to it. So by now you should have been getting familiar to the logic and the concept. So let's move to the next example. So on to example number 4. Consider the function y or f of x equals to square root of x. So feel free to pause the video and find the derivative of this function. So just like before, let's define the formula first. The y dx is equal to f of x plus h I'm about to forget the limit as well, equals to the limit as h approaches 0 of f of x plus h, then minus f of x all divided by h. Perfect. Now since f of x is square root of x, then f of x plus h will be equals to wherever we see x in f of x, we should replace with x plus h, which is simply the root of x plus h. Now we can plug in our corresponding values right in the expression. So we now have the y dx to be equals to the limit as h approaches 0 of square root of x plus h minus square root of x, then all divided by h. Now what do you think we can do at this point? Well, we can actually rationalize. Okay, now you need to know that we don't just rationalize the denominator alone. We can always rationalize the numerator as well, as soon as that is what will work best for us. Okay, we can always do that. So let's continue. We can have that limit as h approaches 0 of square root of x plus h minus square root of x all divided by h. So what I will do to rationalize this, I'm going to multiply both the top and bottom by the conjugate of the numerator. So I'm multiplying by the root of x plus h. Then since the sign connecting them is negative, so I'm converting to positive as its conjugate, then divided by the root of x plus h, then plus root of x. I can clearly see that these values will cancel out themselves and result in 1. And 1 times this expression to give the expression back. So it means I've not really done something out of the box. Okay, perfect. So now let's expand the term. So we now have the limit as h approaches 0. So let's multiply the root of x plus h multiplied by the root of x plus h. Since the term within the root or radical are similar, so this will be x plus h. For those who might be wondering why they are equal, you need to know that the root of a times root of a is simply equals to a. This can be shown out from some of the law of indices. Okay, well, keep that in mind. Perfect. Now the root of x plus h times positive root of x, so that gives positive root of x plus h multiplied by root of x, and negative root of x multiplied by root of x plus h, we have that to be equals to negative root of x and root of x plus h. And now finally, negative root of x multiplied by positive root of x will result in negative x. Perfect. And this is divided by the product of this and this as well. Okay, so h times this, instead I won't expand, let me just put it within a bracket. Okay, that's h multiplied by root of x plus h, then plus root of x. Perfect. So now we are out of space. Let's get rid of some stuff, so we don't need this anymore. So now we have the y dx to be equals to the limit as h approaches 0 of Notice that these terms cancels out. They are like terms and with opposite sign. Okay, the cancels out. This cancels. Negative x cancels positive x. So left over is just h. So we now have h divided by h multiplied by root of x plus h. Then minus, oops, I know that very nicely. Let's do that again. Plus h. Okay, then plus root of x. So now h cancels out. We now have the limit as h approaches 0 of 1 divided by root of x plus h, then plus root of x. Now notice that as h approaches 0, if we substitute what is approaching right in the expression, that won't make us to have any undefined function. So we can go ahead. So we now have 1 divided by root of x plus 0, then plus root of x. Simplifying, we have 1 divided by root of x plus root of x. And since they are like terms, they are addable, then we have 1 divided by 2 root of x. And therefore, we have our final answer, which implies that if f of x is equal to root of x, then its derivative f prime of x, or dy dx, is simply 1 divided by 2 root x. And now you know what the derivative of root of x is and how to find it. So let's move on to the next example. Now on to example number 5. So consider a function f of x equals to 1 over square root of x. So by now you should have been used to the techniques. You can feel free to pause the video and try this one yourself. So after that, you can now unpause it to confirm your answer. So just like before, let's define the formula first. The y dx is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Now, if f of x is 1 over square root of x, then f of x plus h will be equal to what? Well, all we need to do is to replace x plus h, is to replace x with x plus h, wherever we find x in f of x. And therefore, we now have 1 divided by square root of x plus h. Perfect. Now we can plug in everything right in the expression. So therefore, the derivative, the y dx, now becomes the limit as h approaches 0 of f of x plus h, which is 1 divided by square root of x plus h. So 1 divided by square root of x plus h, the minus f of x, which is 1 divided by square root of x, 1 divided by square root of x, then everything entirely divided by h. So first, I would like to combine the numerator before reciprocating. So I hope this space will be enough. Let's continue. The limit as h approaches 0. Now the LCM is root of x plus h times root of x. However, another way you can do this is to multiply these and these by root of x plus h times root of x. Okay. So now, if the LCM is root of x plus h times root of x, now what will be the corresponding numerators? So root of x plus h in this entire expression, we are left with root of x. If we multiply by 1, then we have root of x. And root of x in this whole expression gives root of x plus h. If we multiply by 1, we are left with negative root of x plus h. And we still have it to be dividing h entirely. So now we can reciprocate at this point, okay? So let me get rid of this. We don't need it anymore. So now we have the y dx to be equals to the limit as h approaches 0 of square root of x minus root of x plus h, and divided by root of x plus h times root of x. Now, instead of this long division that is associating h with them, I'm converting into regular divided by h. So now we can reciprocate. We now have the limit as h approaches 0 of root of x minus root of x plus h, all divided by root of x plus h, root of x, then multiply by 1 over h. Okay, you change the sign and you flip this. Okay, that's the reciprocating techniques. Okay, that equals to the limit as h approaches 0 of square root of x minus square root of x plus h, all divided by h, multiply by, okay, let's just multiply everything, root x plus h, then root x. Perfect. Now at this point we are going to do something similar to what we did in the previous example, and that is we are going to rationalize by multiplying both the top and bottom by the conjugate of the numerator. So we are rationalizing the numerator and not the denominator. Okay, so therefore the y dx will now becomes the limit as h approaches 0 of root x minus root x plus h, all divided by h root x plus h root x. Now we're multiplying by the conjugate, that's root x plus root x plus h, then divided by root x plus root x plus h. So just make sure you're taking the steps one after the other to avoid silly mistakes. So now we have the derivative to be equal to the limit as h approaches 0. Let's expand this. Root of x times root of x gives us x, and the root of x times root of x plus h give us positive root of x plus h. Also, negative root of x plus h times root of x gives us negative root of x plus h root of x. Well, they are the same term anyway. These are like terms, regardless of the order. And finally, negative root of x plus h times positive root of x plus h gives us negative, then I've put it in brackets since the binomial x plus h. Okay, then I've written entirely divided by. Now we still need to expand the denominator. Okay, so instead what I will just do is just do h root x plus h, then root x, then multiply by root of x plus root of x plus h. Okay, don't really expand it saying you want to distribute, you're causing more problem for yourself. So just leave it like that. Okay, perfect. So this is equal to the limit as h approaches 0. Now notice that these cancels out. Okay, they are like terms, they cancels out, and left over is x minus x plus h, then divided by the entire denominator, that's h multiplied by root of x plus h. Okay, root of x, and again multiply by root of x plus root of x plus h. Okay, perfect. Now simplifying forward, we now have the y dx to be equals to the limit as h approaches 0 of excuse me, let's expand the bracket. We now have x minus h, negative take effect, and everything entirely divided by h with x plus h root x, then multiply by root of x plus root of x plus h. I hope you are not getting confusing with my repetition of root of x and root of x plus h. Okay, just listen attentively and watch carefully, closely. So we have the limit as h approaches 0. Now notice that negative x cancels positive x and left over is negative h. Then everything entirely divided by h, root of x plus h, root of x, then multiply by root of x plus root of x plus h. Notice that the h cancels out and left over is the limit as h approaches 0 of negative 1, everything entirely divided by root of x plus h, multiplied by root of x, then everything entirely multiplied by root of x plus root of x plus h. Now notice that at this point, as h is approaching 0, if we plug in 0 as h in the function or in the expression, that won't make us to have any undefined function. So we can go ahead. So we now have the y dx to be equal to negative 1 divided by root of x plus 0, root of x multiplied by root of x plus the root of x plus 0. And simplifying forward, we have the y dx to be equal to negative 1 divided by root of x times root of x in the bracket of root of x plus root of x. Perfect. And finally, the y dx tends to be equals to negative 1 divided by, since these are multiplying themselves, we have x multiplied by 2 root x. You can see these are like terms and we are adding them. So multiplying them again, we have negative 1 divided by 2x root x. And this turns out to be the derivative of the function y equals, or f of x equals to 1 over root x. By the way, this x and root x are multiplicable, so if you want, you can multiply them. However, the answer can be left this way. But let's simplify to this form. So this is equals to negative 1 all divided by 2x multiplied by x to the power of half. Okay, with x is the same as x to the power of half. So this is like this is power 1. So we are adding them. So final answer is negative 1 over 2 x to the power of 3 over 2. Okay, by the time we had the index. So that is it. On to example number 6. By now I want to believe that you should be able to find the derivative of any function regardless of how it looks like, okay, using the first principle. So let's consider the last example before we end this video. So consider the function f of x equals x plus 1 over x. So how can we find the derivative of this function? So feel free to pause the videos and figure this out yourself. Well, you will see video 1 that we do it because I changed my mind. So take it as an exercise, find the derivative of the function and name your solution in the comment section below. Thanks for watching. If you have any questions, feel free to let me know in the comment section below. Also, feel free to subscribe to this channel so you can always be the first to receive the notification whenever I upload a new video. And also give it a thumbs up for YouTube to recommend the video to many more viewers. Thank you. See you in the next video. Bye for now.